In this video, I will show you how to work problems on self-test, sig figs, and data. In a previous video, I went through a PowerPoint on significant figures, and now we will use that information to answer questions on the self-tests, which will be good preparation for the graded quiz. Okay, question 1. A tiny piece of paper is weighed on a triple beam balance, and the mass is reported to be 0.001 grams. How many significant figures are there in the number 0.001 as used in this context? Well, this is a measurement, so it follows the rules of significant figures for data. And we know that all non-zero digits are significant, so that 1 at the end is significant. But zeros at the beginning of a number are not significant. And even if the zeros are after a decimal point or to the right of a decimal point, they're not significant if they're not preceded by anything significant. So this number has only one significant figure. Okay, question 2. You open a piggy bank and find that it has 300 pennies in it. How many significant figures are there in the number 300 as used in this context? Well, the 300 here comes from a count of discrete objects, that is, objects that never come in fractions. And so this number is exact. The number of pennies is 300.000 and so on, with the zeros after the decimal point going on forever. And those zeros are significant because they're after a decimal point, they're preceded by that 3 at the beginning of the number, and you have an infinite number of those zeros, all of which are significant. So you have an infinite number of significant figures. Okay, question 3. A chemist measures a water sample in a graduated cylinder and finds that its volume is 10.25 milliliters. How many significant figures are there in the number 10.25 as used in this context? Well, we've got all non-zero digits being significant, so that's the 1, the 2, and the 5. And then the 0 is between significant digits. And zeros between significant digits are significant. So all 4 of those are significant. Okay, question 4. The length of a wire remaining on a spool is 1007 millimeters. How many significant figures are there in the number 1007 as used in this context? Well, we got a 1 at one end of the number and a 7 at the other end, which are both significant because they are non-zero digits. All non-zero digits are significant in measured data. And then we got 2 zeros that are sandwiched in between the 1 and the 7. And zeros between significant digits are significant. So all 4 of those are significant. We will answer that we have 4 significant figures. Question 5. A small piece of paper is weighed on an analytical balance and a mass of 0.1070 grams is reported. How many significant figures are present in the number 0.1070 as used in this context? Well, we've got, of course, leading zeros, or zeros at the beginning of a number, are not significant. So that 0 that comes before the decimal point is not significant. All non-zero digits are significant, so the 1 and the 7 are significant. We have a rule that says zeros between significant digits are significant. So that 0 between the 1 and the 7 is significant because it's sandwiched in between significant figures. You could also say it's significant because it occurs to the right of a decimal point and is preceded by a significant digit. And finally, the 0 at the end of the number is also to the right of a decimal point and is preceded by a significant digit. So the first zero, the one before the decimal point, is not significant, but all the other digits are significant. So the 1, the 0, the 7, and the 0 are all significant, giving us 4 significant figures. Okay, question 6. A long cable is reported to have a length of 5,000 meters. How many significant figures are there in the number 5,000 as used in this context? Well, this is a number that ends in zeros without a decimal point being shown. By default, the decimal point is assumed to be at the right-hand end of a number, but it's not been explicitly given. It just says 5,000, not 5,000 decimal. If the decimal had been there, it would indicate that all those zeros are significant. But in the absence of that, we don't know how many are significant. That could have anywhere from 1 to 4 significant figures. It may be 5,000, give or take about 1,000, 5,000, give or take about 100, 5,000, give or take about 10, or 5,000, give or take about 1. And so we can't tell which of those zeros are really significant, which would really convey something about the number, and which are just there as placeholders to locate the position of the decimal point. So our number of significant figures is indeterminate. Hey, question 7. A chemist weighs out 10.0050 grams of NaCl to make a saltwater solution. How many significant figures are there in the number 10.0050 as used in this context? Well, this number begins with a 1, which is, of course, a significant figure because it's non-zero. Then we've got a 5 down there that's also non-zero, so it's significant. We've got a string of 3 zeros between the 1 and the 5, which are significant because they are zeros between significant digits. And then the 0 at the end of the number is to the right of a decimal point and is preceded by a significant digit, that 5. So all of those digits have been classified as significant. And we have 1, 2, 3, 4, 5, 6 if we count the digits. They're all significant. So 6 significant figures. Okay, question 8. There are 3 feet in a yard. How many significant figures are there in the number 3 as used in this context? Well, this is a definition. A yard is not measured to be 3 feet, it's defined to be 3 feet. So the number is exactly 3, and therefore it's 3.000 and so on, going on forever. And those zeros are to the right of a decimal point and are preceded by the 3. So they're significant zeros, and there's an infinite number of them. So our answer here is infinite. Okay, question 9. A small crystal of table salt is found to have a mass of 0.0092 grams. How many significant figures are present in the number 0.0092 as used in this context? Well, those first 3 zeros there are zeros at the beginning of a number. So only the 9 and 2 are significant, and we have 2 significant figures. Question 10. A chemistry instructor takes roll and notes that 20 students are present in class. How many significant figures are there in the number 20 as used in this context? Now, a common wrong answer here is indeterminate because the number ends with a 0 and no decimal point is shown. And if this was a measure of like 20 inches of string or 20 milliliters of water, then it would be indeterminate. Okay, a measurement ending with a 0, 1 or more zeros and no decimal point would be indeterminate. But this is a count of discrete objects. Students don't come in fractions. So 20 students is exactly 20 students. Or you could say 20.000 ... right, with the zeros going on forever. Those zeros are after a decimal point. They're preceded by something significant. There's an infinite number of those zeros. So we have an infinite number of significant figures. Remember, anytime the number can be classified as exact, the number of zeros will be, or number of significant figures rather, will be infinite. Anytime the number can be classified as exact. Okay, question 11. The length of a wire is reported as 1,000 millimeters. How many significant figures are there in the number 1,000 as used in this context? Now, this is another number that ends with a 0 and does not have a decimal point, just like that 20 we had earlier, the previous question. But that 20 was an exact number. It was a count of discrete objects, in that case, students in a classroom. But this is a physical measurement. You don't count millimeters, you measure them. And so we can't tell, just by looking at it in that way, how many figures are significant. You know, how precisely was that 1,000 millimeters determined? Okay, I don't know in that form. It could be give or take about 1,000, only one significant figure. Could be give or take 100, in other words, two significant figures, and the last two zeros are not significant. Could be give or take 10, so then two of the zeros are significant, but the very last one is not. Could be give or take 1 millimeter, where all three are significant. Although in that case, I guess a dot could have been put after the last zero, okay, to indicate that all are significant. But the person writing it may have forgotten to do that. So I really can't tell in that form how many are significant. So it is indeterminate. Okay, number 12. There are 60 minutes in an hour. How many significant figures are there in the number 60 as used in this context? Well, an hour is 60 minutes because it's defined to be 60 minutes, not because it was measured, right? No one measured the length of an hour with a stopwatch to find out that there were 60 minutes in it. That was a definition. So the number of minutes in an hour is 60.0000 ... Okay, going on forever. It's another case of an exact number. And anytime a number is exact, the number of significant figures is infinite. Hey, question 13. Which of the following numbers has one significant figure? At midnight, there was only one car in the parking lot. No, that has an infinite number of significant figures because that one car is 1.000 ... cars. Okay, infinite. It's a count of discrete objects. A water sample has a volume of 1.0 milliliter. No, that has two significant figures because the zero in that number is after a decimal point and is preceded by a significant digit. So that number has two significant figures. Remember, we're looking for the one with 1. Okay, then we have all of these. I guess it scrambled them, so all of these could refer to anything you see here, but we've already found that some of these two up here do not have one significant figure, so clearly it's not all of these. Okay, a water sample has a volume of 0.1 milliliters. That one has one significant figure because all non-zero digits are significant, so that 1 is significant. That 0 before the decimal point is a 0 at the beginning of a number and is not significant. So this is the only one of these that has one significant figure. So then that lets none of these out as the answer because we did find one that has one significant figure. And so that's our only answer. A water sample has a volume of 0.1 milliliters. That measurement has one significant figure. Okay, question 14. Which of the following numbers has the greatest number of significant figures? Okay, well, 9.2000, remember zeros after a decimal point are significant if they're preceded anywhere in the number by significant digits. So we have 1, 2, 3, 4, 5, right? We have 5 significant figures there. Okay, 0.9200. Okay, that's only going to have 4 because the leading 0 is not significant. The other zeros are significant because they're after a decimal point and preceded by a significant digit, but that's only got 4 significant figures. We've already found one with 5. Okay, that lets out they all have the same number of significant figures. We know that already. They don't, because this first one has 5, this one has only 4. 0.0092 grams has only 2, because those 3 zeros are zeros at the beginning of a number and don't count as significant figures. And then 0.0920 has 3. The leading zeros don't count. The 9, the 2, and the ending 0 are all significant. So we have 5, 4, we have 2, and we have 3. So this one at the very top here has 5 significant figures. That's the one with the most figures. Okay, 15. When a number contains an infinite number of significant figures, the number is an exact number. Exact numbers have an infinite number of significant figures. Okay, number 16. Which of the following has the greatest number of significant figures? 0.09 grams. That has only 1. Because the zeros there are zeros at the beginning of a number. Only the 9 is significant. Okay, 0.9, that also has 1. 0.009 has 1, because all of these beginning 0 or zeros at the beginning of a number are not significant. That last one, 0.000, 3 figures, 0.0 or 3 zeros, 0.0009. So all of these numbers have only one significant figure. So there's not one with a greatest number. They all have the same number of significant figures. They have one significant figure. Okay, number 17. Match each of the following measurements to the number of significant figures it contains. 0.0076. Okay, only the 7 and the 6 are going to be significant. That will have 2 significant figures. 0.1090 grams is going to have 4. Only the leading 0 is not significant. That has 4. 0.0102 grams has 3. The 2 leading zeros are not significant. That has 3. 50.0170, that has all 6 of these are significant. All the zeros you see in there are between significant digits. Okay, so all 6 of those are significant. And then 16.000 has 5. All those zeros are after a decimal point and are preceded by something significant. Okay, and then number 18, how many significant figures are there in an exact number? An exact number has an infinite number of significant figures. Number 19, which of the following numbers has 3 significant figures? 300 millimeter piece of string, no, that's indeterminate because it ends with zeros without a decimal point, and it's a measurement. 0.005 grams of salt. That only has 1 significant figure, right? We're looking for 3. 0.05 grams of salt. That still has only 1 significant figure. 40 milliliters of water in a graduated cylinder. That does indeed have 3, and then 135 cars in a parking lot is infinite. And then finally, number 20, match each of the following measurements to the number of significant figures it contains. 1.250 contains 4. 0.0012 contains 2. 30.0 contains 3, 0.001 contains 1, and 10.050 contains 5. Okay, and then we're ready to submit our quiz with only seconds left, but we got it done. And you probably wouldn't take as long to do it because you don't have to explain it. You just have to do it. And so I kind of took a little bit longer explaining it. And even with having to stop and explain it, I finished it in the allotted time, although with very little time left. It would have auto-submitted for me in about 8 seconds if I hadn't hit the submit button. And there's our grade, 100 out of 100. So we know that all of those answers were correct. So I hope those explanations help you. And that's my video on significant figures in data. And then I'll be making another video on significant figures in calculations.